All right, welcome back to video number 2. Now that you've had a chance to check out the PhET website and play around with that little app to build your own circuits, you should have answered a few of these questions. So the first thing you should have done is make the light bulb light up, which I think I did in the video previously, so you should have been able to do all right. And then you were supposed to try switching out some of the wires for different substances. So you had things like, for example, if I go back, you had things like instead of a wire, you could have put in an eraser or a paperclip or a dollar bill. Now the question is, what did you notice were insulators and what did you notice were conductors? Well, what you should have noticed is that the conductors all were metal, right? So they all allowed electrons to flow through fairly easily. The insulators were non-metals, things like rubber, all right? The third little part of it was, are there any that are, I'm not going to be able to see that well. Are there any that are kind of in the middle? And if you had actually put in a pencil as one of them, you should have noticed that it works, but it works really, really slowly. And that's because graphite does allow electrons to flow through it. It just doesn't do it particularly well. Now, that being said, there is hope for the future that it could be used as a very good conductor of electricity. But in current days, with current technology, it doesn't work particularly well. All right, so let's move on to the second part. So we're going to talk specifically about, in this video, the different parts of electric circuits and the different types. All right, so if you take a look at this picture over here, you can see a fairly simple little circuit. We've got a battery, we've got some wires, we've got a switch, and we've got a light. And realistically, those are the 4 major components that you would need for an electric circuit. Now, you can have it significantly simpler, but to have a usable, decent, safe circuit, this is what you would need. Now, in order for electricity to flow, it has to be what is called a closed circuit. And that means that there has to be a complete path for the electrons to travel. So if we go back here and take a look, you can see that electrons can travel out of the battery and reach this point, but they're stuck. There's no way for them to make it all the way around. So in order for them to actually be able to complete the pathway, you need to join these 2 ends. Now, you could do it by simply just joining the wires, but then we cause a fire. So that's obviously not a good idea. What we actually want is to put something in between here that would either control the flow of it, or better would be to help use up some of the energy in the electrons. So something like, for example, a light bulb. All right. So if there is a break in the circuit, for example, if the switch to the right up here is flipped up, then it's now called an open circuit. And that means the electrons are not going to be allowed to flow. So if I were to add in here, for example, let's cut that out, and we'll put the switch in. Look at that. You can see that right now that switch is open and the electrons are not able to flow. And that is because there's a break in the wire. But if I were to close that switch, you can see now that there's a pathway for the electrons to flow and the light bulb can actually light up. The electrons can complete a circuit. Okay. So let's look at some of the specific parts to an electric circuit. So number 1, an electric circuit has to have an energy source. Now, that could be something like a battery, for example. This is the basic idea of what a car battery would look like, for example. Or it could be a AA battery, it could be a C cell, that sort of thing. It could be a generator. There are a number of different types of energy sources. That is required to actually energize and push the electrons around the circuit. All right, so we need something to make those electrons move. All right, for it to be a complete circuit, we need 4 parts. Now, I mentioned this earlier. We have this that is simple, that is similar to the one that I showed earlier. We have an energy source. That's our battery. We have wires that are going to connect that energy source to the various components. We have what is called a load. Now, in this example, it is a light bulb, but it could be anything that requires energy. And then finally, we have over here a very simple switch. And in this case, it is simply a piece of wire that can be added or removed. And that switch can be any number of things. In the previous slide over here, you can see that that looks like a switch that you could actually lift up and down. But it could be something like a light switch, for example, that you would find in your home. All right. Now, you'll notice that in this example, we have a complete loop. Right? So the electrons come out of the terminal, they hit the light bulb. We have a switch that controls whether the electrons can flow or not, and then the electrons go back to the battery. All right? Now, that is what is called a controlled circuit. That means it has a switch that is used to open or close the circuit. Now, you can also have what is called a fused circuit. And in a fused circuit, you have a fuse or a breaker, which is a safety device that will stop too much electricity from flowing. Now, these sort of things you will find in vehicles. For example, they're also found in your home, controlling the power to all of the various plugs in your house and to all the lights in your house. All right. We can also have what is called a short circuit. Now, in a short circuit, I've actually shown you what happens to this a couple of times. We have a energy source, and we have wires to allow the flow of electrons, but there is no load, right? That means that there is nothing that is slowing down and consuming the energy of those electrons. And what happens is when any two substances rub against each other, there's friction, and that friction creates heat. And that applies to electrons going through a wire as well. So when those electrons flow through the metal, they are rubbing against the metal. And if there's nothing slowing them down, and there's nothing taking their energy, they are going to rub very fast and very hard. And what that ends up doing is creating more and more and more and more heat. And if there is nothing that is actually preventing those electrons from slowing down, the wires can heat up to the point where they actually melt or they burn, right? And that's why electrical fires are such a danger. And that is why the circuits in your home actually have breakers or fuses. And those breakers or fuses are designed to break, in other words, stop the flow of electrons if the current gets too high. So if there are too many electrons going by, if things are going too fast, if it's creating too much friction, that fuse or that breaker will actually create an open circuit, and then the electrons stop flowing. All right? All right, folks, so just a quick note. I have changed the second image to a different one. So if you're just watching the video, make sure you watch the slideshow. All right, so now what I would like you to do is we have seen 3 different circuits in the current video. What I would like you to do is go back to that FET website and try to build these circuits. Now, not only are you going to build them like this, but you're also going to try to figure out how to then draw them using circuit diagrams. So what you're going to do is, instead of drawing a light bulb, you're going to replace it with its symbol. Now, in order to do that, you are going to have to open up the attached file that has the circuit symbols, and you're going to have to replace, so when you're drawing this, instead of drawing a switch that, well, actually the switch kind of looks the same. Instead of drawing a light bulb that looks like this, you're going to have to draw it using the symbol. Now, a little trick for you, if you look down here, you can see there are 2 images. One shows a battery, and one shows this symbol. What you do is click on this, and it'll actually show you the symbols that can be used to replace the drawings or the images that you've already seen. Now, it's a little hard to see with the electrons there, so if I click that, you can see it without the electrons. All right? So if if you look over here on the left, you can see in the menu, it's no longer pictures of things. Now it's pictures of symbols, right? So these are different symbols that you can use to actually put into your circuit, right? So try drawing these three. You might want to try making them in here first and then switching it between this and this, and then draw out those circuits on a piece of paper, okay? As well, I want you to describe the circuit for each one of those as, is it complete or incomplete? Is it controlled? Is it open? Is it closed? Is it fused? Or is it a short circuit? Right, so every one of these circuits, you could use at least one, if not multiple, of these descriptions to describe what it is. All right? So once you've done that, come back, and I'm going to show you what each of them should look like.